right, we are working number 4 from the trig sub homework. When we started this, I said let's remember that e to the 2x is the same as e to the x quantity squared. And so that rewrite is helpful. In assisting us in making our triangle. And we have subtraction in here, so that's going to be a leg. I'm going to put it over here. What does that make our hypotenuse? Thank you. And it makes our other leg e to the x. So let's list the things that we have to get rid of. Right now, I'm just doing the indefinite integral portion.
I have a question. Why is the hypotenuse 3?
Because this is c squared minus b squared under the square root. So that has to be the hypotenuse, the square root of 9. All right, so the things we need to get rid of are e to the x, the square root of 9 minus e to the x squared, and dx. So we list the things that we need to get rid of. And now we go to our triangle to help us rename them in terms of theta and d theta. So e to the x, well, I see cosine is adjacent over hypotenuse. So cosine theta is equal to e to the x over 3. So 3 cosine theta equals e to the x. Now, I would put a cloud around that because that would take care of this guy, but I've done this so many times that I'm just going to hold off a second. We also need to get rid of dx. So I'm going to take the derivative of this guy, and take a look what our derivative takes care of. It takes care of both e to the x and dx together. So I'm going to put a cloud around that one. That's the one I want to use. Okay, so I have those two taken care of. And now what would I use to take care of the square root of 9 minus e to the x squared? Sine, cosine, tangent?
Sine.
Sine, yeah. So I'm going to say sine theta is equal to opposite 9 minus e to the x squared over 3. And so 3 sine theta is equal to the square root of 9 minus e to the x squared. And I'm going to put a cloud around that one. Some people may have chosen to use cosecant, and that's fine. The way we plug it back into the integral is a little different, but as long as you do it algebraically correctly, you're fine. Okay, so now I think we have everything we need. So we are looking at the integral of 3 sine theta is the square root of 9 minus e to the x squared times negative 3 sine theta d theta. Max, are we okay with that?
Yep.
I'm going to pull the negative 9 out in front. I have sine squared theta d theta. So now I'm going to use my identity. One minus cosine of 2 theta over 2 is what sine squared theta is. I'm going to pull the 1/2 out with the 9. And I'm going to be looking at negative 9/2 integral of 1 minus cosine of 2 theta d theta. All right, if we take our antiderivative now, we get 9/2 times theta minus, what would I get from the cosine 2 theta, Max?
1/2 sine theta.
Sine 2 theta.
Sine 2 theta.
Yep. Now, we use another identity. because our triangle is not written with 2 thetas. It's written with just thetas. So before I go back to x's, I make that change. And we'll have 1/2 times 2, that's 1. So sine theta, cosine theta, plus c. That's a c. Okay, and now we can go back to our x's. We'll have negative 9/2 theta, if I get to my triangle, is cosine inverse e to the x over 3. Are you okay with that? Minus sine theta is the root over 3. And cosine theta is e to the x over 3, close my bracket, plus c. There's my antiderivative. Does that make sense?
Yeah.
Okay. Now I have to go and plug in these things, which gets a little ugly, but that's okay. Ours is not actually an indefinite, it is a definite integral. So I'm going to get rid of my plus c and say to be evaluated between ln of 3/2 and ln of 3. Okay, here we go. So negative 9/2 cosine e to the ln 3 is just 3. So this is cosine inverse of 1 minus the square root of 9 minus e to the ln of 3 is 3 squared, so that's 9, over 3 times 3 over 3. Are you okay with all of those substitutions?
Yeah.
Minus, bracket, negative 9/2, parenthesis, cosine inverse of e to the ln of 3/2 is 3/2 over 3 is 1/2, minus 9 minus 3/2 squared is 9/4 over 3 times 1/2.
Students, please excuse the interruption. In a few minutes, we'll be leaving second period and going to our common lunch.
All right, and I'm just plugging in and trying to continue here. We have negative 9/2 times pi thirds minus. So this is 3 root 3 over 2 over 3, so those are gone, times 1/2. Looks like root 3 over 4. And you can get a decimal answer from there if you wish.
Okay, thank you.
Yep, are we all right? That's good?